Hello, students. In this video, we will explore the amazing world of forces. Forces are all around us, and they are essential for motion and interaction between objects. So let's get started. When we apply force, it can make objects start moving, stop, change speed, shift direction, or even alter their shape. Now, let's discuss balanced and unbalanced forces. Balanced forces happen when different forces acting on an object cancel each other out, resulting in no change in motion. Imagine a book resting on a table. Gravity pulls it down while the table supports it upward, balancing the forces. On the other hand, unbalanced forces lead to changes in motion. For example, when a car accelerates, the force pushing it forward overcomes friction. Forces can be either contact forces, like the push of a hand or the friction between surfaces, or non-contact forces, like gravity, electrostatic, and magnetic forces that act at a distance. Now, let's discover Newton's first law of motion. It states, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced external force. This means that objects tend to keep doing what they're already doing. For instance, a book will remain still until you push it, and if a car stops suddenly, you might feel a jolt forward due to inertia. Inertia is the resistance to changes in motion. Whether an object is stationary or moving, it will resist any change unless an external force acts on it. So, a book stays put unless pushed, and a sudden stop in a car makes passengers feel like they're being pushed forward. Inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. Next, let's talk about momentum, which is a measure of how much motion an object has. It's calculated by multiplying mass by velocity. Momentum has both magnitude and direction. Now let's explore Newton's second law of motion. This law explains the relationship between force, mass, and acceleration. The formula F equals mxa shows that heavier objects require more force to accelerate, and the more force you apply, the faster an object will accelerate. The formula F equals mxa shows that heavier objects need more force to accelerate. The greater the force applied, the more an object accelerates. Impulse is another important concept. It measures how a force applied over time changes an object's momentum. The formula ILFXT helps us understand this. For example, when you hit a baseball, a large force applied in a short time changes the ball's speed significantly. Let's understand gravity. Gravity is a force that pulls objects downward. It's weaker as distance increases, but always acts on everything. Near the Earth's surface, the acceleration due to gravity is about 9.8 ms2. Weight is the force of gravity acting on an object, calculated as F versus mxg. Weight, calculated as F equals mxg, is the force due to gravity. Next, we have Newton's third law of motion. This states that, for every action, there is an equal and opposite reaction. This means forces always come in pairs. When you push against something, it pushes back with equal force. Lastly, the conservation of momentum principle tells us that in a closed system, total momentum stays the same before and after interactions. This means momentum doesn't disappear. It just moves between objects. Now here is a question for you. Which type of inertia describes an object's tendency to continue moving in a straight line? Please share your answer in the comments. The complete curriculum for Class 9 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.